Good morning. In this session, I am going to continue with some more problems given in previous Jeemain on the topic laws of motion, right? Let's move on to the problems. Look here. See, I have already completed the previous 55 problems, so let's start with 56. Statement 1. Three forces F1, F2, F3 are represented by the three sides of a triangle such that F1 plus F2 is equal to minus F3. Then these forces are concurrent and satisfy the condition for equilibrium. That is perfect. Just if you take this to this direction, it is F1 bar plus F2 bar plus F3 bar. Resultant of three forces simultaneously acting on a point is 0 implies the three forces are concurrent and they keep the point in equilibrium, right? So, the first statement is correct. Now, look at the second statement. A triangle made up of three forces as its sides taken in the same order satisfy the condition for translational equilibrium. Remember the triangle law of vectors. When three forces simultaneously acting on a point, if they keep that point in equilibrium, then they are represented by the three sides of a triangle taken in order. So, from this it is F1 bar plus F2 bar plus F3 bar is equal to 0. So, those three forces simultaneously acting on a point are represented by the three sides of a triangle taken in order. They keep the point in translatory equilibrium. So, this statement is perfectly correct. So, it is just based on triangle law of vectors. Let us move on to the next problem. A body of mass 10 kg is suspended vertically like this. It is pulled aside by a horizontal force F through an angle theta. And what is the applied force, horizontal force? We know from tangent law, horizontal force required to pull it aside through an angle theta is mg tan theta. If you have that in your mind, look, it is F is equal to m is given as 10, g is given as 10, tan theta is given as 45 degrees, tan 45 is 1. So, it is just 100 Newton. That is the correct answer. I think you know the proof for that. See here, I am just telling you the proof once again because I explained you this during the explanation of the synopsis, but still I am explaining. This is mg, this is F, and this is the tension in the string. Let us resolve this tension into two components. This is T cos theta, this is T sin theta. T sin theta balances F, T cos theta balances mg. As a result, F by mg is equal to tan theta or F is equal to mg tan theta. It must be perfectly there in your mind. Come on to the next problem. A wooden block of mass 5 kg rests on a soft horizontal floor like a cloth, right? See here, a wooden block is placed on that cloth. When an iron cylinder of mass 25 kg is placed on the top of the block, the floor yields and the block and the cylinder together go down with an acceleration of 0.1 meter per second square. The action force of the system on the floor. Look here. When a block of mass m is placed here, its weight mg acts in the downward direction. So, the reactional force R is equal to mg, right? Here, let us see another case. Suppose the next, in this we are going to see a special case. This is mg is acting on it in the downward direction. if the surface is given a downward acceleration on this block, a pseudo force Ma acts on it in the upward direction. So, the force with which the block presses the ground becomes m into g minus a. As a result, the reactional force developed on the block will be m into g minus a. Just look into this problem here. In this problem, the block and the cylinder together are of mass 5 kg plus 25, 30 kg. And this moves down. When the cylinder is put over the block, this is and it's moving down with an acceleration 0.1 meter per second square. The actional force of the system on the floor. What is the force with which this presses the ground? So, F is equal to m into g 9.8 minus a, because it is this is moving down with acceleration. So, exactly this is the explanation where the force with which the block presses the ground or the system presses the ground is m into g minus a. This is 30, 9.8 minus 0.1 is 9.7, 97 into 3. 3 sevens are 21, 3 nines are 27 plus 2, 291 Newton. This is the correct option for that problem. Simply, if you go back, apparent weight of a body in an accelerating lift, isn't it? When the lift is moving up with acceleration A, apparent weight or the force with which the block presses the floor of the lift is m into g plus a, when the lift is moving up with acceleration. When the lift is moving down with acceleration A, the force with which the block presses the ground or its apparent weight m into g minus a. If you have that in mind, it is simply m into g minus a. That's all is enough to solve the problem. Okay? Now, move on to the next problem. Consider a block and trolley system as shown in the figure. Coefficient of kinetic friction between the trolley and the surface is given as 0.04. You need to find out the acceleration of the system. Look here, acceleration is net force divided by total mass of the system. Here net force is equal to mg minus frictional force Fk is mu k, if this mass is m, mu k mg, right. So, net force is equal to mg, because this force is trying to pull the system, whereas frictional force is trying to oppose the motion of the system. So, mg minus mu k small mg. Look here, m is 6, 6 minus mu k is 0.04, m is given as 20 into g is given or no? G is not given here. See here, g will take it as 10 because mass is given as 6, weight is given as 60. So, from that g is given as 10 indirectly. Okay, that is the net force. So, net force is 6 minus 0.8 into 10. It is 52. And acceleration is force divided by mass. Mass is 20 plus 6, 26, implies acceleration is 2 meter per second square. That is the answer. So, this is the net force. Net force divided by total mass of the system is equal to the acceleration of the system. Move on to the next. Look here, follow this carefully. In the given arrangement of doubly inclined plane, this is of angle 53, this is of angle 37, two blocks of masses capital M, small m are placed. The blocks are connected by a light string passing over an ideal pulley as shown. Coefficient of friction is given as 0.25. The value of m is how much? For which the value of capital M is 10 kg. When this is moving down, this 10 kg is moving down with an acceleration of 2 meter per second square. Value of g is given. You are supposed to find out the mass of the block. Look here very carefully into the problem. Let us recall certain things. Here on an inclined plane, suppose if this is an inclined plane, when a block is placed on a rough inclined plane, the net force acting down the incline is mg of sin theta minus mu cos theta. That is the force acting on it down the incline. Okay, if you want to pull the block up the incline, force needed to pull it up the incline is mg of sin theta plus mu cos theta. We have derived all these things by drawing free body diagram, considering the frictional force also. Now let us consider here force acting on this is F1 and force acting on this is F2. Net force is equal to F1 minus F2. Because it is moving down, force F1 is in this direction, whereas F2 opposes its motion. So F1 minus F2 is the net force. See, F is equal to F1 is mg sin theta minus mu cos theta. Since it is moving down, theta 1 minus small mg sin theta 2 plus mu cos theta 2, because it is moving up the plane with the same acceleration. So this is the most important part of the problem. Let us try to find out the net force. M is given as 10 kg here, G is given as 10, sin 53 is 4 by 5 minus mu is 0.25, cos 53 is 3 by 5 minus small m we need to find, G is 10, sin 37 is 3 by 5 plus mu is 0.25, cos 37 is 4 by 5. See here, you might be wondering how I am telling sin 37 and all those things. He has given here tan 37 as 3 by 4. This is 37, tan is opposite side by adjacent side. From Pythagoras theorem that becomes 5. So sin 37 opposite by hypotenuse 3 by 5, cos 37 adjacent by hypotenuse 4 by 5. This is a right angle triangle. So this will be 90 minus 37, 53. So from this triangle sin 53 is opposite by hypotenuse 4 by 5, cos 53 is 3 by 5. Even that, if you are very strong in problems, if you practice number of times, we pretty much know all those values, right? So just like that I have substituted. So this is, we can take this 5 as common factor, cancel that. So it is 20, 4 minus 0.75 is 3.25 minus, we can take this 5 as a common factor. So minus 2m, 3 plus 4.25 is 1. So net force is equal to 3.25 into 20. It is 65, 32.5 into 2, 65 minus 3 plus 1, 4 into 2, 8m. So this is the net force acting on the system. Force is equal to m into a, isn't it? Force is equal to m into a. So here net force is equal to m plus m into a. F is 65 minus 8m. M plus m is 10 plus m into a. Acceleration is given as 2 here. So, 65 minus 8m is equal to 20 plus 2m. So, just take this to the other side, it becomes 10m. 20 to this side, 65 minus 20, it is 45. So, m is equal to 45 by 10, it is 4.5 kg. So, in this problem, it is a bit lengthy, it is simple but a bit lengthy, you have to do the calculation very carefully. And the most important concept is, this is moving down, force on it is mg of sin theta minus mu cos theta. As this is moving up, force on it is mg of sin theta plus mu cos theta. So, as those two forces are opposing one another, net force we have taken it as F1 minus F2 and net force is equal to M1 plus M2 into A. That is the concept behind the problem. So, let us go to the last problem for today's session. See, 3 blocks are pulled on a horizontal smooth surface by a force of 80 Newton as shown. Tensions T1 and T2 we need to find out. See here, in this, acceleration of the system is net force divided by total mass of the system, 5 plus 3 plus 2. So, acceleration is 5 plus 3 is 8 plus 2 is 10, 80 by 10, it is 8 meter per second square. Just if you draw the free body diagram here, this is a 5 kg. An acceleration produced is 8 meter per second square. That acceleration is created by the tension in the rope T1. So, T1 is equal to m into A, that is 580s or 40 Newton. So, T1 is equal to 40 Newton, right. Coming to T2, look here, 5 plus 3, together it is 8 kg. And this system is moving with an acceleration 2 meter per second square, that is being created, acceleration is 8 meter per second square, isn't it? Here acceleration is 8 meter per second square created by tension T2. So, T2 is 8 8s are 64 Newton. So, the answer is 40 and 64, option 3. Is it okay? So, I will stop here for today. I will continue with some more interesting problems in the next session. Thank you and bye-bye.